Hello mathematicians, this is the second part of video 118 and we're going to get into the actual using proportion word problems. So before we start I want to define one thing for you, and that is the word rate. A rate is a ratio between two different measurements that describes a relationship. So a ratio between two different measurements that describes a relationship. And let's maybe make that describes a relationship look a little bit clearer. Describes a relationship. Now, think about how these things relate. A rate is a ratio between two different measurements that describes a relationship. A ratio itself, if we think back to video 1, a ratio itself is a comparison between two numbers. So what a rate is in comparison to a ratio is we're just saying now these two numbers relate in a way that forms some kind of pattern that's happening, right? So, for example, I might say the price of $2.99 per dozen eggs. So right now, I'm creating a rate. I'm relating the price and how much a dozen eggs costs. Now let's kind of think about what this actually means. Dozen, okay, I know dozen is another word for 12 eggs. So I might say, okay, I pay $2.99 per dozen eggs. Remember that the word per means divide. I could also write that I pay $2.99 per 12 eggs, okay? That's a rate. We're figuring out how do these two measurements relate and what is their relationship with one another. And so we can see that I pay $2.99 for a dozen eggs. The relationship between those two things, between this rate, is that for every dozen eggs, I'm going to pay $2.99. Okay, let me do another example. I might say a speed of X miles per 8 hours. So I know I'm going to go X miles. Okay, I know per means divide. So per 8 hours. The rate that I'm creating here, the ratio I'm creating here, or the rate is that every X miles per hour, right? We don't know how many miles I go every 8 hours, okay, but we can use a variable to substitute that. But I know I'll go X miles every 8 hours, or X miles per hour. All right, I want you to try and do example 3 and 4. Try to set up what this rate would look like. Go ahead, pause the video. When you're ready, press play, and you can see the answers. All right, here are your answers. For example 3, you should have had $35,000 per year. And for example 4, $5.89 per 1 gallon of milk. Now, something I want you to pay attention to is that on both of those examples, on all of the examples we just did, we used units. And that is extremely important because units help us figure out the relationship that's actually happening when we're talking about a rate or a ratio or proportion. Because we have to understand what two things are we comparing. Are we comparing, let's say, miles to seconds? Are we relating miles to hours? Though units are very important. All right, so let's go into example 5, and we're going to start to really see what this objective is all about, and that is solving proportion word problems. So I'm going to put this up here. Okay. And when I'm using this, I'm going to go through this problem, and I'm going to use cups. So it says Trent goes on a 30-mile bike ride every Saturday. So every Saturday he rides 30 miles. He rides the distance in 4 hours. He rides the distance in 4 hours. At this rate, how far can he ride in 6 hours? So how far can he ride in 6 hours? Okay. Now, before we go into how to solve this problem, this is the type of problem that we want to use something called a USA box on. And a USA box is something we use when we are solving problems that involve proportions or rates or ratios. So let's just kind of brainstorm what words we might see that could symbolize to us, oh, this is a USA box. Okay, one word, we just saw this word, the word rate. If you see the word rate, it probably means you're going to use a USA box. Not all the time, but it probably does. If you see words like pace, if you see words like ratio, if you see a comparison being made between two things, or a scale being made between two things. These are usually words that signify to us that we need to use a proportion. And we're going to use a USA box to do that. So let's first kind of talk about what our USA box is. Our USA box is a way to set up your proportion that allows you to use units to make sure you're getting the right answer. So the USA box stands for this. U stands for units. S stands for scale, and A stands for actual. And I'm going to set my USA box up like this. I'm going to put USA at the top, and then it kind of looks like you just filled in the top row of a tic-tac-toe board with the U, S, and the A. So if you see I have like a tic-tac-toe board and I filled it in. So listen, U stands for units. So what are the two units we're dealing with in this problem? Well, I'm going to go back up and I'm going to read. We have Trent goes on a 30-mile bike ride. So one of my units is miles. Trent goes on a 30-mile bike ride. Okay. And he rides that distance in 4 hours. Okay, so his distance is 4 hours. Okay, those are my units. Next, I'm going to write in my scale. Now I have to go back to the problem and look, what are the two things that they are relating to each other? So it says Trent goes on a 30-mile bike ride every Saturday. He rides that distance in 4 hours. Okay, so these two numbers are linked. He rides 30 miles on his bike. It takes him 4 hours. Now I'm going to line the miles up with miles and the hours up with hours. He rides 30 miles on his bike. That means that I'm going to put the 30 by miles. They're lining up with each other. He rides it takes him 4 hours. I'm going to put the 4 with hours because 4 refers to hours. At this rate, remember rate was telling us to use the USA box. At this rate, he can ride how far can he ride in 6 hours? So 6 hours, that is a measurement of time. So I'm going to put the 6 next to the hours in the hours row. Now, we're figuring out how far he can ride. Far, that's a measurement of miles. That means I'm going to solve for miles, and I'm going to put my variable there. Now we're just going to solve this proportion. I'm going to put an equal sign in between these two things. And it's like, I'm going to move this over, it's like we just created two fractions, okay? We're going to cross multiply. 6 times 30, x times 4. So first I'm going to do 30 times 6 equals x times 4. I'm going to go ahead and I'm going to simplify that to be 30 times 6 is 180. I'm going to rewrite 4 times x as 4x. Now I'm going to make a quick do and undo box to solve this. What's happening to x? It's being multiplied by 4. How do I undo that? I'm going to divide by 4. So I'm going to divide both sides by 4. 180 divided by 4 is 45. My 4's cancel out, and I'm left with x. So my answer is 45. Now, you should ask yourself, what is my answer? It's not just 45. It needs the units. So what would my answer be? Well, 45, and what are my units? What's nice about a USA box is you can see that the variable is going to line up with the units. So you see how x is with the miles? They're lining up, so my units are miles. So how far will he go in 6 hours? 45 miles. Okay, let's go ahead and do another example. All right, looking at example 6, as I read, I'm going to use cups. So it says a long distance runner ran 1/4 of a mile in 2 minutes. How many minutes would it take them to run 8 miles if they ran at the same pace? Okay. And then it also asks us to answer how many hours and how many seconds. Now for this one, think about what word in here tells you that we should use a USA box. And we should have seen the word pace. The word pace tells us, okay, this is going to be a USA box. So I'm going to go ahead and set up my USA box. I'm going to look and see what were my 2 units. We have a long distance runner that ran a mile in 2 minutes. It's asking us how many minutes would it take for them to run 8 miles. And then it also asks us how many hours and how many seconds. You should use the units they give you in the comparison. So the comparison gives us miles and minutes. So I'm going to use those 2 units. Miles and minutes. Let's zoom in a little bit so it's a little clearer. Miles and minutes. Now, I know we eventually need to change our answers into hours and seconds as well, but we can do that at the end. For right now, we're just going to use what they gave us. So, we know he runs 1/4 of a mile in 2 minutes. At that same pace, he's going to run, how long does it take for him to run 8 miles? Well, 8, that's a measurement of miles. So I'm going to put that with miles. And I'm going to solve for minutes. I'm going to cross multiply. 1/4 times x. And 8 times 2. Go ahead and simplify. 1/4 x is equivalent to 1/4 times x is equal to 1/4 x. 8 times 2 is equal to 16. I'm going to divide both sides by 1/4. And we get that x equals, these cancel out, 16 divided by 1/4 is 64. Now, to make sure I know what my units are, I'm going to come back over here and I'm going to look. My x was with the minutes, so 64 minutes. Okay, let's talk about how we would change our answer into hours into seconds. We will talk about conversions in our next unit, in Unit 4. For right now, just know that if you want to go from minutes to hours, think about this, minutes to hours, that means the time, the amount of time the number is going to get smaller because 60 minutes is equivalent to 1 hour. So to go from minutes to hours, we're going to need to divide by 60. And to go from seconds, we're starting with minutes. To go from minutes to seconds, okay, the number of seconds is equivalent to less minutes, okay, so that's going to mean we're going to multiply by 60. So if you want to do this problem, and I'll just do it down here, we're going to cordon off some space right here. 64 minutes, if I want to figure out what that is as hours, I'm going to divide by 60. And that gives me 1.06 repeating hours. If I want to go from 64 minutes to seconds, I'm going to times by 60. And that gives me 3,840 seconds. Okay. Don't worry too much about converting right now. We want to just make sure we can do our USA box. That's the most important thing for this objective. All right, let's do one more together, and that's example 7. The Munoz car requires 5 gallons of gas to travel 120 miles. So 5 gallons to travel 120 miles. How much gas will they need for a 350-mile trip? Okay, now, this question doesn't have anything in particular that screams out USA box, but what it does do is it's giving you a comparison. It's giving you a rate, 5 gallons every 120 miles, and we can change that rate and apply it to another measurement like mile trip. So that's telling me I want to use a USA box. So I'm going to go ahead and set up my USA box. Looking for my units, it's telling me 5 gallons of gas to travel 120 miles. So I'm going to make my units gallons and miles. All right, I know it's going to take me 5 gallons of gas to go 120 miles. It's telling me we're going to go on a 350-mile trip. That's miles, and I'm going to solve for gallons. So now I'm going to go ahead and I'm going to cross multiply. We're going to do 5 times 350, 120 times x. 5 times 350 gives me 1,750. That equals 120x. I'm going to divide both sides by 120. And I get that x equals 14.583. Repeating. Think for a second, what do you think the units would be? The units would be gallons because our x lines up with gallons. Okay, let's go ahead and let's try a couple practices. I'm going to have you skip this first practice, and I want you to try practice 2, 3, and 4. 2, 3, and 4. When you're ready, go ahead, pause the video, and then when you're ready, press play, and you can see the answers. All right, for practice number 2, you should have had 7.5 minutes, or you could have had 450 seconds. For practice 3, you should have had $720. And for practice 4, you should have had 1.275 hours, or 76.5 minutes. Make sure you write down any questions that you have and come to class ready and prepared to practice.